Let's try multiplying rational expressions. So one good strategy to try is to factor. So you see some trinomials and we're tickled to factor. What times what is 12? Yet adds to be -1. Let's try this. What about the denominator? Let's use difference of squares. The dot means multiply. Again, we have a trinomial, and we're tickled to factor. Let's try -3, -1. Looks good to me. And let's factor out an x. So what we have here is x minus 4. And this is where we set off some fireworks. The x minus 4 cancels all the way across. And we have x minus 3 that cancels. We can even cancel x plus 3 top and bottom. And this is not bad at all. So what we have left over is x minus 1 over x. That's pretty clean. Now we did simplify, but we also need to find the domain. The domain is not only x does not equal to 0. It's every single restriction for every single second of the way after you factor. So here this used to be a 4, x minus 4, so therefore x does not equal to 4. And looking at these, x does not equal to plus minus 3. So these are all domain restrictions for this entire rational expression. Now let's do something similar for dividing. So we're going to factor the numerator using difference of squares, and we're going to factor the common factor x squared minus 4. And here we better leave that division sign alone, because we should factor first. X, what times what is 6? And the numbers look right, trinomial factoring. And we try trinomial factoring again on the bottom. So right away, we can factor further with difference of squares over here. So let's just cross this out and write this in fully factored form. Using difference of squares, we have x plus 2 and x minus 2. So right away, before you do anything, you need to start stating some restrictions. Every single step of the way. X does not equal to 0, comma, plus minus 2. X does not equal to -5, also 4. Now when we change this division sign to multiplication, we flip the numerator and the denominator. So let's do that. So notice how we copied the question again, but we changed division to multiplication by flipping this. And when we flip the numerator denominator, we may be introducing more domain restrictions. Be careful. Now, did we already say that x does not equal to 2? We already said that, so we don't have to worry about this one here. Now, what about x does not equal to -3? That causes a divide by 0 as well, a problem. And we didn't say that before. So this here is our new domain restriction. And now it's time to set off some fireworks. So looking top and bottom, we can knock off the x plus 2's, the x minus 2's, and that's about it. So what we have now is x plus 5, x minus 4, all over x minus 2, x plus 3. If you really want to expand these out, you could, and that would also be simplified. Alright, now it's your turn.